Okay, now on to the next step of your analysis. In the previous videos, we first georeferenced our aerial photograph. This one is from 1955. Then we created an area of study, polygon. We clipped our uh, georeferenced aerial photograph, and then lastly we classified the raster values between the three succession stages of sand, grass, and forest. So now we're going to look at the data and do some analyses. That's what we're actually kind of doing all of this for, this last step. So this is how you do it. You first, here is the clipped area of study. You want to right click and open the attribute table. What do we see here? What is this attribute table? Now, how many pixels are that in the clipped image? Hundreds of thousands maybe? I don't know. And there's only 253 or so entries in this attribute table. How is that possible? Well, what it is that the object IDs and the values are unique, are not unique. So that's why they have this third column count. So an object ID is called object ID 1 if the value is 0. And there are 24 pixels that have a value of 0. For the value of 1, these are very dark. I mean, 0 is as dark as you can get. It's black, black. There are 3. And we defined 0 to 76 as black, as forest. So up until 76, value of 76, all of these are black. And remember that all the pixels have the same area. All the pixels are the same size. It's a picture element, pixel. So we can export this and go into Excel to do more analyses. And I'll just show you how you do that. Come up to the top left of the attribute table, and you go down to export. You want to export all the records, and so you click here, which way you're going to export it. And actually, I've already done it, so I'll just select it. Well, let's call this analysis 1955. But just to save it over again, and you want to save as type text file. Maybe you've never done this before, but you can easily import a text file into something like Excel, which is what I'm going to use. So go ahead and save that, analysis1955.txt. Okay, and then click no. All right, we're finished now, in this video at least, with ArcMap, and we're going to open an Excel session. I'll start a new blank worksheet. You go to Data, insert data from text, because we just saved it as a txt file. Remember, I saved it under GS data. We want, what was it, 1955, analysis 1955 is the one we just saved. Click import. We're not quite finished. Delimited means that there's something that tells Excel to move on to the next cell. So that's what we want. We don't delimit. You can even see here, it's delimited by a semicolon. So delimited, next. Then, like I said, it's a semicolon. Now suddenly you see, hey, it's good. Next, finish, and start in cell A1. Correct. There's only one little thing, is that the count is way off because it's converting from a different decimal system. So you need to convert that to the normal 24. So you equals C2 divided by, let's see, did that right? There you go, count of 24. Now remember, we defined, let's go back to ArcMap, we defined forest up to a value of 76. So we scroll down to this value of 76. Yeah. And we enter equals sum open parentheses, and we select everything from 76 to 1, actually to 0. And we see that there are 2,488,000 pixels approximately that are black forest. The other value was 162. So let's go down to 162. Okay, equals sum up to 76. All right, there are only 452,000 approximately pixels which we classify as grass. And lastly is the highest values, white, that's sand. And we do that again. Oops, forgot the open parentheses. Scroll up. And parentheses. And there are 519,101 pixels that are white. We need to find the total number, so that's again one last sum. Scroll all the way to the top. Here we are. In total, there are, what's that? 3,459,613 pixels in total. We eventually want to find out the percentage, right? So that's one of your most important analyses is the percentage of each type of land. So we do that by the pixel analysis. So we have this divided by the total, hit F4, and we see 0.15. I like to show that in percentages. Maybe a couple more. There we go. So it's 15.00%. That's pretty phenomenal. 15% sand. Copy that, and you paste that here. 13.08% grass. Oh, wait, I'll copy it again. Copy that. And 71.92% forest. And these are the values that you want to then do for each year to see what the succession rate is over what is that, 60 years, from 1955 till 2015. And then divide by the number of years so you see how much each one grows or decreases each year. And you want to make graphs and charts and make it very pretty. Much better analysis than I've done in just these last few seconds. Let's see, I can even put them next to each other. It should add up to 100% if I did it right. Let's see if I did it right. Okay, there you go. So that's totals 100%. So I guess I did that right. Good. Thank you for your attention. Again, like I said, do this for each year so that you can see how the succession has changed. This is exactly what Laurens Bryce did in his article. Thanks for your attention and have fun.